Hey everyone, I am Arpit and welcome to the Cube Simplify YouTube channel. And we have Dinakar with us, and we are at KubeCon India. Now, this is the second day, and the vibe is amazing. And if you don't know him by any chance, he is a senior principal engineer at Red Hat, and I am so glad that we have him right here. So you are at KubeCon. So how you are feeling the vibe? Like KubeCon India is happening for the first time.
Thanks, Arpit. Yeah, it's the first time that it's happening, and it's a very big conference, lots of attendees, lots of good topics. I've got to learn a lot. And also, we are talking about our project out here as well. So, yeah, it's been a very good experience so far.
Yeah, so I know Red Hat is working on a couple of projects, but would you like to share what is the problem you are trying to solve and what is the exact project you are working on?
Yeah, so I work on a project called Kruize, and it's all about resource optimization. So you might have heard about in the KubeCon keynotes, resource optimization is one of the key problems that customers are facing these days. So that's exactly what is being addressed by this project called Kruize.
Also, I can guess it is open source, right?
Yes, absolutely. So it is available on GitHub. You can go to github.com/Kruize, Kruize.
Can you explain a little bit about Kruize, what it does, and how it basically solves the problem? Like what unique you are doing from the rest of the market and competitors you have?
So Kruize does actually three things. It provides right-sizing recommendations for CPU memory, GPUs, and namespace recommendations as well. So you might have heard about vertical pod autoscaler. It's a Kubernetes project that's already out there. So Kruize is actually a superset of this VPA. So what we have done is that Kruize monitors your application over long term and then comes out with recommendation that says, how much CPU, memory, GPU, and namespace, that you actually need based on usage. So the usage could be based on the last 1 day, 7 days, or 15 days. And it provides two different kinds of recommendations, cost-based recommendation or performance-based recommendation.
Oh, so basically you are handling the cost side as well as the performance side. So I can guess it's the kind of doing an autoscaler thing, right?
Yes. So a specific example is, let's say that, for example, that you have an AI workload. These days we know that GPUs are very, very costly, very hard to find. So you do want to make sure that the GPUs are being used efficiently. And so what Kruize does in this particular case is that it monitors your AI workload and then checks, how much GPU cores and GPU memory is it actually being used. So what we do then is to, interact with another open source tool called as InstaSlice. So InstaSlice, what it does is that it actually dynamically creates partitions on NVIDIA GPUs. So NVIDIA has a new feature called, for some of the GPUs, called as multi-instance GPU, or MIG. So what this MIG is that, we know that not every application requires the entire GPU. So you can partition the GPU into smaller slices called as MIGs. And what InstaSlice does is to create these partitions dynamically. And what Kruize does is to monitor your application over a long period of time and say, okay, you actually only need, out of all the number of cores that you have in the GPU, maybe you just need 2 GPU cores and let's say 10 GB of GPU memory. And then we will tell InstaSlice that, okay, can you carve out a partition for me in this way? And so that your application can use only that part of the GPU memory. So that's the auto-scaling part.
Yeah, so basically the InstaSlice, basically what it does, it is basically clear from the name itself. It's kind of a slice, part of a GPU, right? Also, exactly. I can put it out in this way. We do partition on the hard disks in Windows. It's a similar kind of a thing, right? For viewers to understand.
Yes, exactly. So it is partitioning the GPU. The thing is that, for CPUs, we can make use of it very, very granularly. You can say that I'm assigning 0.01 core to a particular application, but we cannot do that with GPUs. So that is the problem. But what NVIDIA has done now with MIG is to, maybe not so granular, but at least have a smaller slice. Like for example, a full GPU, for example, can have 7 GPU cores, but it can be sliced into, let's say, 1 GPU core or maybe 3 GPU cores, and it can be partitioned dynamically. So when we are monitoring the AI workloads, not only do we look at the GPU usage of the AI workloads, but it can also resize the CPU and memory as well. Another interesting thing with AI workloads is that they are mostly handled by Q, the Q project, KUEUE in Kubernetes, because it does a very good handling of batch jobs, and typically AI jobs tend to be similar to batch jobs. So in the sense that they run to completion. So what we are doing with Kruize is that we are providing recommendations at a namespace level, which can then be fed to Q to create a pipeline that creates the right sized namespace and then deploy your AI jobs to it as well.
Also, as you have told, like it is an open source project. So can you tell our audience like how they can contribute, and is there any kind of prerequisite for contributing to this project, or how one can get started in a proper way?
Yeah, that's a very good question. So Kruize, as I said, it's a open source project. It's available on GitHub, github.com/KRUIZE. The easiest way for anybody to contribute to any open source project in general is to start with, let's say, a documentation or maybe small bugs. So we would have already, in our project, we have tagged a number of issues as good first issue.
Yeah.
So that's typically a practice that is followed by many open source projects, where they tag issues which are beginner issues as good first issues. And so you can pick those and start with that, maybe contribute documentation. The best way is that we also have another repo called as Kruize-demos in the same repo. If you can try out the demos and you find any issues, then you can either report them, or maybe you can try and work on them and try to fix them as well.
Can you talk a little bit about Kruize tech stack, like what Kruize is using under hood, so that folks who are interested into the specific tech stack can actually divert towards Kruize?
So Kruize is based, it's written in Java.
Okay.
And the reason why we chose Java was because originally Kruize was, one of the goals of Kruize rather is to not only provide right sizing recommendations for containers, namespaces, GPU, as you heard, but also to do runtime recommendations.
Okay.
So basically that means that tuning the Java stack, or maybe tuning the Golang stack and so on, or Spring Boot or Quarkus and so on. So these are also future enhancements that we are planning. So if you would like to contribute to Kruize, in Java is the prerequisite for you to be able to contribute to that. But then there are other parts of Kruize which use Python. We have another project within Kruize called as hyperparameter optimization, which is completely written in Python. There are parts of it which is written in Golang as well. So irrespective of which language you are proficient with, you should be able to contribute to this project.
Do you want to say something to the KubeSimplify audience?
Yeah, I would say, go and try out Kruize. As I mentioned, it's a open source project. We also have a Slack, which is there on the GitHub project as well. So you can come over on Slack and ask us questions. Try out Kruize and let us know your feedback. We really look forward to that. Thank you.
Yeah, this is a very fun interview. Thank you, Dinakar, for your time. I appreciate it a lot.
Yeah, thank you so much, Arpit, for having me as well.
Also, I will be dropping the GitHub repo link in the description. Plus, I will also be dropping the Dinakar LinkedIn handle in the description as well. So you can reach out to him. He is a very sweet and kind person to reach out and have a conversation. And the KubeCon is being amazing, and we will see you in the next KubeCon. And yeah, this is it. Thank you.
Thank you. Yeah.